Good afternoon, everyone. I'm Nikhil Jain from Department of Electrical and Electronics Engineering. This presentation covers my internship, learning, and project implementation at EMERTXE Information Technologies. The title of my project is Smart ECG Signal Detection and Amplification Systems, which is totally based on embedded systems and real-time hardware project. The overview of this internship is known for industry-oriented training in embedded systems. My internships mainly focused on understanding how embedded systems are developed in real world applications. During the internship, I was exposed to embedded hardware, microcontrollers, sensors, and firmware development. I also learned how theoretical concepts are applied practically in real time systems. Online aptitude and basic electronics training, the fundamentals of C programming made easy with this internship. The internship at EMERTXE started with a structured screening process. This included aptitude assignment, basic electronics concepts, and C programming fundamentals. After the screening, we underwent hands-on training in embedded systems and covered microcontroller architecture, GPIO, ADC, and sensor interfacing. Only after completing this training, a real-time project was assigned, which helped ensure that we were well prepared for implementation. The goals of internship were learn embedded system fundamentals, gain real-time hardware experience. The primary goals of my internship were to gain strong fundamentals in embedded systems, understand microcontroller-based system design, and implement a real-time hardware project. Another goal was to improve debugging skills, understanding the complete development of life cycle from requirements analysis to testing and validation, improved problem solving documentation skills. The project which I completed based on embedded system are smart ECG signal detection and amplification. This is the basic flowchart of an project. Here, ECG signals are censored using capacitive electrodes, which this sensor unit block consists of op-amp 550 Hz notch, 110 Hz low power filter, and op-amp. This sensor unit amplifies the signal, which cancels the noise and any other buffers included in the electrodes. These signals are very low in amplitude and cannot be directly processed by a microcontroller. Therefore, proper amplification and filtering are required before giving signal processing. The project description is mainly focused on design, implementation, and practical study of analog signal conditioning circuits for primary of ECG. ECG signals acquired from the human body are extremely low in amplitude and are highly susceptible to various noise sources such as power line interfaces, baseline, vendor, and motion artifacts. This project mainly focuses on which millivolt signals are converted into pictorial representation of an heartbeats. Project requirements. The hardware requirements are ECG sensor, microcontroller Arduino, electrodes, code, power supply. Software requirements are Arduino, serial monitor, and embedded C, which is used to run the code. The overview of embedded system concepts are embedded system is a combination of dedicated hardware and software designed to perform a specific task. This project is based on embedded system continuously monitors ECG signals in real time and performs a specific medical monitoring function without using a general purpose OS. It is a basic block diagram of an project. ECG electrodes are used censored using an AD8232 ECG sensor, which amplifies and filters, using which is sensor signals passed through Arduino microcontroller serial plotter. Finally, the ECG waveform is displayed in the real time using a serial plotter. The software design, which basically portrays the ECG signal via ADC, processes the real time data and display the ECG waveform. The development process carries the design, coding, testing, and debugging. Where debugging used to erase the minute changes in the waveforms and the noise cancellations. The ECG electrodes basically which are sensed on the body, which gives a signal. Implementation of project that initialize the Arduino, reads the ECG signal, processes the signal, and send to the serial plotter, which displays the proper ECG waveform. The implementation helps in proper electrode replacement, noise reduction, stable real-time ECG output. Results: clear and continuous ECG waveforms are obtained where there is no noise cancellation without proper waveform. The output of the waveform may be very accurate so that the because of the high pass and low pass filters. The outcomes of this project are that using the embedded system sensor interface skills have been improved. And through this internship, I learned embedded system design, sensor interfacing, analog signal processing, basics, and debugging tactics. The demo of the project will be very accurate so that the main signals can't be represented. So that I have captured the outputs of the ECG waveforms. In conclusion to this internship at EMERTXE Information Technologies, industrial well, the smart ECG project strengthened my understanding of real-time signal processing and hardware software integration and has built strong foundation for advanced embedded projects. Thank you.